Good evening, everybody. I wanted to get this video done a little earlier than I said because I saw that Blackboard was going to be down tomorrow from sometime to sometime. I think it'll be open back up at like 4 o'clock or something. 1600 for those that like 1600. All right, so first and foremost, so like I told you, like when we get done with this safety thing, right? Like I want you to walk away and think, man, that makes common sense. That is common sense. Like I'm not trying to be tricky. Like, does something make sense or does it not make sense? So the number one thing I want you to approach this test with is the question, does it sound like it's something that makes sense or does it sound like something that doesn't make sense? And based on what we've learned, that's what I want you to walk away with. And I want you to read the questions like that. I don't want you to read the questions like, man, he's like really tricky and these are going to be tricky and he's going to change a word or something. No, I want you to say, hey, based on the stuff we talked about, does this make sense or does it not make sense? Okay. All right. So, for instance, like if something seems like if you did this, would it make things better or would it make things worse? All right. So if I did X, would Y be a positive outcome if that was the intent, right? That's how I want you to look at some of these questions. Okay. All right, so now let's talk about the regulations again. Okay, now we talked about safety regulations. I talked about some big ones. Okay, so biggest industry standard one. I want you to know these regulations and know which ones apply, which ones do what. Okay, so EM 385-1-1. That's the one that's published. I believe it's published by USACE, but the intent is it's the USACE publication. For safety, right? So it applies to all contracts executed in USACE. All construction is like the USACE headquarters thing, right? Awesome safety regulation, okay? Then there is the NFPA 70E. The 70E is that industry standard electrical safety guide. It is the principles behind everything that most people accept industry wide as safety. There's also the NFPA 70, which is also known as the NEC. That thing is intended to safeguard everybody. Kind of serves as that electrical code that's kind of some guiding principles. If you actually read the scope on it, I believe it says something to the effect of it's not a code or it's not a design principle or design guideline or something like that. Either way it goes, people are designing based on that because that's what codes are inspected off of, blah, 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 blah. Anyways, the NFPA 70E is that industry standard for safety, man. Just put that right here. The NEC is the guiding principles behind how you're actually like executing electrical stuff. They kind of both have the same intent. One of them is more of a this is how you do it. The other one is this is what you do so you don't die. Like it's, I don't know, they're different, right? They're different. Um, and then okay, so we have the 29 CFR 1910. That is the OSHA standard. That is that federal regulation that like it dictates, right? The 70E was developed to help supplement and incorporate NEC stuff into the OSHA stuff, and the 70E is that bridge. But the 29 CFR 1910 is the thing that is that federal thing, right? And the NFPA 70E is more of that industry accepted thing that bridges the gap between OSHA and the NEC. So hope you understand that. Then there is also the UFC 3-560-01, which is the what is it, Unified Facilities Code, um, that dictates safety regulations to all electrical safety workers that are underneath the mandate of that UFC, which would be anything contractually obligated to the UFC or any kind of DoD construction or anything like that. All right, so big takeaways. Again, the UFC is a thing that's really just taking all these other outside sources such as the OSHA, the 29 CFR 1910, and the NFPA 70E, and meshing them together into an Army manual. That's what the EM 385-1-1 is doing. That's what the UFC is doing. They're just taking outside regulatory guidance and packaging it into something that they can contractually obligate people to follow. That's really what it is. Okay. All right. So then there is also the AR 385-10, right? The Army Safety Program. So when we talk about like risk mitigation, when we talk about just safeguarding DoD employees and stuff like that. That is going to be that blanket umbrella, that very broad AR 385-10, right? So if we were going to talk about like PPE and like classes of gloves and things like that, you're probably not going to find that in that 385-10. You're talking about risk mitigation strategies and risk reduction matrices and things like that. You're probably going to find that in that 385-10. All right, so understand that. All right, so all right, let's talk about some other common sense things, right? So we talked about like arc flash, arc blast. Um, uh, so when we have an arc blast, think like, right? You've got like explosions and atomizations of materials and vaporization of things, right? Huge energy, all right, happening, right? That's the thing that when we talked about that guy, when he was talking about that transformer, if you were in a cabinet, that thing would head straight towards you, right? You talk about arc flash, all right, that is going to be the incidental arc like explosion. However, it is not that full forced energy, right? Think of like uh, a giant, really a flash. It's like a common sense like of energy, right? A blast, think of like a train punching you in the face with electrons. Okay, think of it like that. All right, and you'll be okay because again, it's kind of common sense with the name. Okay, so let's talk about some boundaries, right? We talked about the arc flash boundary. Okay, that's going to be the furthest point outside of that circle from the actual thing that could be energized. Then the next thing is going to be the limited approach boundary. All right, and then the next thing past that is going to be the restricted approach boundary. Okay, so each one of those boundaries, there's different characteristics of who can be in there, who is qualified, unqualified, things like that. But you need to kind of know what those boundaries are, kind of what's the order of those boundaries. I mean, and be able to kind of explain them. I want you to explain them. You got to tell me about them. All right, not just that a boundary exists and on this little circle chart, you know that that furthest one is arc flash. I'd like a little more than that. I'd like you to know a little bit more of that. Okay, let's talk about PPE. All right, you're going to need to know the glove classification. You need to know that the double aught is 500. The zero glove is 1,000. Let me think. 1, 7,500. 2, let me think. 1, 0, 0, 0, 1, 7,500. 2, is that the 11, 17, 11,000? Somewhere in there. You tell me. All right. And then 3 is going to be the 26,500. And then 4 is the 36,000. Something to that effect. Know those. Okay. I want you to know those. All right. Also, know the testing intervals. Okay. Know which ones are 6 months. Know which ones are 12 months. All right. Know how often somebody's supposed to test their own personal gloves. That's kind of a good thing to know, right? You know, you got to tell your soldiers, like, hey, when do I expect you to test your glove? Same thing with the uh, how often do you regulatory test gloves? Know the difference, right? Like when we say your glove needs to be, one of you in class made mention to this, right? It was a good catch, right? When are you as a person personally inspecting your glove versus testing your glove? Okay. Same thing with PPE. Same thing with hoses, covers, all that stuff. Know it. Cool. All right. Let's see what else is important to know. You need to know what level of current is going to make you feel tingly versus which one is probably going to make you die. It's a good thing to know, right? Kind of helps you assess when you're doing risk mitigation strategies, when you're looking at current levels of potential systems that your soldiers are working on. You know, okay, well, I realize he's dealing with something that's below maybe 16 milliamps, so maybe it's not going to reach out and grab him and hold on to him. Or then you say, okay, well, I've done a little bit of math and I realize that the short circuit current on a circuit that my soldiers give me this risk assessment for is over 75 milliamps. Maybe it's like, 100 milliamps or something. So then I know that, like, holy smokes, that'll cause, how do you say that? Ventricle something, defibrillation. It's going to make your heart die. Okay. You probably need to kind of know the difference. All right. Common sense stuff. Approach distances. It's something that we haven't talked about, okay? But I'd like you to go look at approach distances. Look at approach distances because approach distances, you can find it in probably just about every manual you can find. I can spit all of them out. You're probably going to find them except 385-10 because that's really generic. All right, but you're going to have voltage levels for approach distances, okay? Voltage levels for approach distances. So if you knew you had 1 voltage that was really common, how close could you get it before like it might want to reach out and grab you? Okay, that's that approach distance. You probably want to look at that. All right. man, hey, so common sense stuff, man. Like we talk about like what what could a certain type of inspection probably save you from, right? Well, let's just common sense it, like things like IR surveys, right? You do IR surveys and you look around and you look at things through an IR camera and you're looking to identify things, but really the IR camera is subjective. You just say inspection. What does an inspection help prevent with safety? Well, there's probably like a mile long list of things, right? Because it makes sense. If you inspect something periodically and you put focus into it, it's going to save a lot of things in the long run, right? It's a proactive approach to things. So I just want you to think through that, okay? Like again, it's so much common sense stuff. So much common sense. All right. Let me see. So much common sense. Um, Remember, we talked about grounding and bonding, right? We want to common sense things. We think about Joe Schmo with that generator and he's backing up his house and he's not shutting things down. He's back feeding the grid, right? So if you were to climb up that pole and you were going to work on that line, where are you going to put the ground clamp? Are you going to put it like a mile down the road? Or are you going to put it in between you and the power plant? Or are you going to put it between any different potential direction that current could flow? I don't know. Probably that one. Also, we talked about like where are you going to hook this thing up, right? Are you going to hook it to the line first, or are you going to hook it to the ground first? Because if you do one, you're actually just extending that potential difference to you. If you do the other one, you're actually like being a little bit safer. Okay, that's what I want you to think about. All right. Okay, so colors of stuff, colors of stuff, colors of gloves, colors of lockout tags. Yeah, that would probably be smart. Colors of, we have cautions and clearance tags, right? Those are things that Mr. Velez talked to you about, cautions and clearances. There's only two things. You might want to know what color those tags are. Just saying. Just saying. All right, what else? Man, that's so common sense. I'm not even going to talk about it. God, standards, man, stuff, words. All right, the quiz that we had, the bonding, equipment bonding, equipment grounding electrode, grounded conductor. Know and understand those. Also, all those 250-66, 250-50 something or other. There was 3 tables that we did for that last quiz where you were actually like selecting either a let's see, we're looking at system grounding jumpers, which I believe are system grounding conductors, which those I believe were dictated based on the main overcurrent protection that was near it. Then there was the other two where we were looking at main bonding, grounded conductor. There was one table that covered a lot of things, right? And it was all based on the largest size service conductor coming in. All right, we're not. I don't want to wrap your head around like, oh, what if I put like 15 of a parallel thing through this one conductor? And I don't want to make it tricky or anything. I want you to understand the basics and understand it. So I want you to focus on, hey, how do I do this? So if you can navigate that quiz, you should be fine. Okay, the thing you need to focus on is one. There's 3 tables. 2 of them look identical. One of them goes off overcurrent protection. Look at the question. What's the question asking you? First, pay attention to the size and material of the service entrance. Then look at what it's asking for. Is it asking for an equipment grounding? Is it asking for a uh, grounded conductor, main bonding jumper? Is it asking for a grounding electrode conductor, right? Or system grounding conductor? Look at what it's asking for. And then look at what material it says you're asking for, because that could be a different material than the main service entrance, right? So you could have copper wire coming in and you could have aluminum wire as your grounding. There's a whole bunch of different things that happen. Science, right? So just pay attention to the question to make sure you're looking at the chart right, because you don't want to confuse yourself and say, okay, well, there's copper service entrance, so I have to look at the copper side of the output of the table. That's not the case. All right, pay attention. All right, if you have any questions, post on the discussion board and we'll talk it all out. All right. Um, let's see. Don't forget the 3 things. The 3 things, they're common sense. They should be common sense at this point that make a an effective ground, right? You have to have a low impedance path to ground, right? If you create resistance between the fault and where you're trying to get it back to the overcurrent protection in the source, You create resistance there, you're creating a hair dryer, and you're no bueno, right? You need a low impedance path to ground, all right? You need a continuous connection, right? And then you need to have a, let's see, largest, you need to have the ability to carry all that current, right? Think about that video, and that dude showed that giant pole and said, lightning's going to strike this, and it's going to go through this little bit tiny wire, right? That's not going to do anything because the wire is going to melt. It's going to be like a fuse link. So we need to have continuous path to ground, continuous path, right? We need to have a current carrying capacity of the fault of the system, and we need to have a low impedance path to ground. Understand those three things, please. I said them in a bunch of different words, but understand what like I'm saying, please. Let me see here. Hey, just gonna throw this out there, man. There's so much common sense on here that I don't want you to think I'm trying to be tricky. Common sense. It's awesome. And that is it. I don't want to talk anymore. This is great. I hope you guys are doing the quizzes. I hope you listen to this. I don't have anything to write for you because this is legit going to be some common sense. Don't let it trick you. Don't let anything trick you. I want you to be able to read the question and go, does that make sense based on what I learned, or does it not make sense? Or if it asks you a question, you better, I hope you know the answer. But a lot of the questions, they're going to be common sense ones. I hope. If not, maybe I'm a terrible teacher. I don't know. But good luck. I hope you watch this. I'm going to post this tonight, Saturday night, so you don't have to wait till Sunday. And then I'm going to stalk you on Blackboard to see who actually watched it or not, and then see if that correlates to good grades or not, because I do all that stuff. Anyways, you guys have a great weekend, and good luck Monday.